Cursor's starting to jump around, but wow. We'll see how far I can go without me having to reboot. But all right, what are we doing tonight?
I've got a quiz tomorrow about the law of sines, cosines, and like using sine tangent and cotangent to fill out a triangle.
Okay.
And then, so I think reviewing for that is probably our best bet.
Okay.
Because I have a week and a half to final, so actually like a week, but I don't know. Okay. So the first one is a little weird. It says, because of prevailing winds, a tree grew so that it was leaning 6 degrees from vertical. At a point 100 feet upwind from the tree, the angle of elevation to the top of the tree is 22 minutes, 50 seconds?
All right, I'm confused already. Let's start again. With a tree.
Okay.
It's bent?
Yeah, 6 degrees away from vertical.
Okay, that's pretty close. So this would be a what angle here? What would this angle be right here?
Like a 94 degree angle? Or 84?
6 degrees.
Oh,
6 degrees inside of a right angle. Okay. In other words, this is the 96 one here. Okay. So it's got 6 degrees of bend in it. Okay, and then what else does it say?
At a point 100 feet from the tree, the angle of elevation to the top of the tree is 22 minutes, 50 seconds, I think.
22 degrees, 50 minutes?
Yes. 50 minutes, yeah, there we go. Sorry. And wants to find the length of the tree.
Which is x.
Yeah.
What trig function works for this? Oh, gosh, I just realized this is not a right triangle. That's why we're using the law of sines. Okay. What's this angle right here? In other words, in order to use law of sines, we have to establish a relationship between one side and one angle, opposite it. Well, I know this angle. I know this angle, I can figure out this angle. And then I will have that relationship because I'll have that angle and I'll know the side opposite that angle is 100. So what's this angle here?
Well, see, I don't know how to figure that out.
Okay, they have to total 180.
Well, yeah, but then can you just, like, what do you do about the second minute?
Okay, let's change 50 minutes into a decimal. How many minutes are in a degree?
I don't know.
60. There's 60 minutes in a degree, and there's 60 seconds in a minute.
Oh, okay. That makes sense.
So that really is 22 and 50/60ths degrees. Which, what is 5/6? That's like 0.8 something? 0.84 maybe?
8.3.
Okay.
I think.
Okay.
4, I don't know.
So now we need to figure out this angle here. Well, normally that angle would be 67 degrees 10 minutes plus 6 more degrees because this angle is not a right angle. So this angle has to be 73 degrees and 10 minutes or 73.16. With me?
Yeah.
Okay. Now apply the law of sines that will allow me to solve for x. Let's rewrite this as 22.84. So what equation can I come up with?
To find the other, okay.
Apply the law of sines to this triangle right now.
Yeah, wouldn't you use the law of cosines?
No, because I actually have an angle and its opposite side. That is where you always want to use the law of sines. Where you use the law of cosines is when you don't have that relationship.
Okay.
Okay? Whenever you use the law of cosines, you have to also use the law of sines. In other words, the law of cosines, I don't believe ever solves for it. You still have to use the law of sines after that. The law of cosines merely gives you one angle, which then allows you to have that angle opposite side relationship. So using the law of sines, what can I write?
You can write, so it's sine,
Start with the angle that has the opposite side.
okay, so the sine of 37.16.
Isn't that 73.16?
Yeah, sorry. I got mine.
Okay. All divided by what?
All divided by, oh, I don't want to check my notes, the opposite side?
100
Yeah.
equals what?
Equals the sine of, what would you do? I guess, well, if you're solving for the tree, yeah, you 22.84 over x.
Exactly. There's three numbers and a variable there.
Okay.
So we can solve for x. And that's all we need to solve for here. They didn't say solve this triangle. If they'd have said solve the triangle, then we need to do one more to solve for z. The sine of 84 degrees divided by z is this same ratio. Basically what the law of sines says is that the ratio between the sine of an angle and its opposite side is the same within that triangle. Every angle in that triangle has that ratio. Okay? Should we go on to the next problem, or do you need to come up with a specific answer here?
No, that's fine. I can do
Okay.
it.
I think since we're only doing a half hour, it's probably best if we get these set up and dispense with the arithmetic. What's the next one?
Okay, this one is one of the ones that I have trouble with, so that's that. Two ships leave a port at 9 a.m. One ship travels at a bearing of north 50 degrees west, or 50, yeah, I don't know. Yeah, north 50 degrees west.
Yeah, what that means is we start from north and we go 50 degrees towards the east. Let's go to the west. Okay, so that ship is going like that.
Okay, so north 50 degrees west at 12 miles per hour, and the other ship at a bearing of south 67 west at 16 miles per hour.
Okay, I think that's what.
Approximately how full are the ships at noon that day?
I think that's what a bearing of south 67 degrees west means.
Okay.
For both of them. Okay? Now what?
Okay. It wants to know how far apart the ships are.
At the end of 1 hour, or? Because obviously they're going to get further apart as time increases.
Yeah, so at noon that day, and it's currently 9 a.m.
Okay.
in the province.
So after 3 hours.
Yeah. Mm-hmm.
What is this triangle that I'm creating here? In other words, that would be the triangle after 1 hour. Right?
Yeah.
Okay. So after 3 hours, this ship's going to go 45 miles.
Okay.
This ship is going to go 36 miles. And we need this distance. Call it x. What's this angle here? This angle right here.
So you would take 180 and do 67.
Uh-huh. In other words, that angle plus 50 plus 67 have to add to 180.
Yeah.
So that angle has to be
63.
63. Okay. Now, notice that is all we have is side, angle, side. We don't know this angle. We don't know this angle. This is a law of cosines problem. In other words, it's not immediately law of sines because we can't figure out an angle and its opposite side. If we could, we would use the law of sines. Whenever you have this side, angle, side situation, now we can use the law of sines to solve this. So what does the law of sines say about x squared? What is x squared equal to?
X. Oh, man. The law of sines?
No, law of cosines.
Oh, okay. Sorry. I was like, I don't know that. It's equal to the square root of the first sine?
It's actually the square of the first. Think Pythagorean theorem.
Yeah. Sorry. Did I say square root?
Yeah.
Sorry.
So that's the first part, because that's what we would use if it was a right triangle. But it's not a right triangle, so I have to subtract off what?
2 times the side times the other side.
Time
And then times the cosine of the angle.
of the angle that is opposite the x. Always that angle. Okay? So,
Yeah.
what is this? Now this, notice that this is just arithmetic left. Cosine of 63 is a number. So we have x equals to the square root of all of that.
Okay.
Okay? And that you can get from your calculator.
I like these ones because you can just plug them in.
Okay?
Okay.
So, actually I was wrong. In other words, if we had to solve this whole triangle, they only ask us to solve for x. But if they wanted us to solve for these angles, say angle A and angle B, in other words, your standard problem in your class is going to be solve this triangle. And when they say solve a triangle, they want all 3 sides, all 3 angles. These word problems they're giving you, you only need to end up solving one side of a triangle. So you don't need both the law of sines and the law of cosines. This problem we solved strictly with the law of cosines. But if they said, okay, solve the triangle, now we have a number for x. Let's say x is 75. Just picking a number out of thin air. Well, now we have one side and its opposite angle. Now we revert to the law of sines to finish solving the triangle. And that's the way it always is. If you're solving triangles and you have to use the law of cosines, you're going to have to use the law of sines next, after you solve for that one side that is key. Okay?
Okay.
Probably the best practice we could do is solving some triangles. Do you have some of those? Rather than these word problems. Not that the word problems...
Yeah, I do.
I mean, we need to do the word problems too, but they're actually easier because you're only solving for one side of a triangle.
Okay.
Yeah.
So, okay.
Have you covered
Given
the case, the ambiguous case of the law of sines?
Yeah, and I was actually wondering if we could go over that because I missed that day and I'm really confused.
Definitely. There's an easy way to do that. There's a hard way to do it. Let's do it the easy way.
Okay.
Let me give you an example.
Okay.
We can't tell, unless you've memorized the rules for where you can possibly have an ambiguous case. First of all, the only time you can ever have it is if you have a side-side angle, which is what we have here. In other words, if you have side angle side, there's only one triangle that can come out of that. If you have angle side angle, there's only one triangle that can come out of that. But if you have side-side angle, and the angle is less than 90 degrees, this is a potential case where you might have two possible triangles. How could I get two possible triangles? Like this. Notice sides are still 8, 10, and that angle is still 40. But we're looking at a completely different triangle. Okay, so this is an example of the ambiguous case. But now let's see if we can figure out whether it's ambiguous by solving this triangle, and I'll show you how to do that. So let's start by trying to solve it. Step 1. Call this A, B, C. Use the law of sines to solve for angle C.
So, the law of sines?
Yeah, because we have an angle and its opposite side. Whenever you have that, it's always the law of sines. It's never the law of cosines. Law of cosines is only when you have side angle side or side side side. Then you have to start with the law of cosines. You always finish with the law of sines. But some of the initial problems you have to start with the law of cosines if you do not have a side and its opposite angle. What we do here. So what can I say?
You'd say sine 40 over 8 equals the sine of x, I guess.
No.
Or c.
Over
10.
Okay. Now let's solve that for sine of c. That means the sine of c is equal to 10 times the sine of 40, all divided by 8. What number is that?
I'm plugging it in. It's 0.803.
Now, how do I get c?
You do the inverse.
Okay, what do you get for that?
Inverse 53.46.
Okay, now here's where you check for the ambiguous case. In other words, it looks like we're done. But not really, because notice there's two inverse sines of 0.803. What is the other angle that actually is true also from your trig?
For sine c?
Yeah, in other words, if the sine of c is equal to 0.803, then c is not just 53.46 degrees, it's also, there's a second quadrant angle. What else could c be? And this is the step you have to take every time you do this. 126.54. In other words, the supplementary angle.
Okay.
Okay. Now, can we have that angle for angle C? Well, if I go up, yes we can.
Well, yeah.
I made angle C. In other words, if I draw the thing like this, this angle, it would be possible to stick 126 degree angle in there. This one's 40. If the sum of this angle and this angle is less than 180, then you can have this situation. If the sum of this angle and this angle is greater than 180, then you can't have this situation. And that's how you decide whether you have the ambiguous case of the law of sines. Is when you go to solve for C, if you get two possible solutions and they are both possible, then you can have both those angles. Now notice that in this second drawing, B is different. That's okay. Everything else is the same. That's still 10, that's still 8, and that's still 40. So the three key pieces of information that we were given, the only three pieces, fit this triangle also, as well as this one. So that's why it's called the ambiguous case. In other words, if I tell you you have a triangle that has two sides that are 8 and 10, and this angle is 40, you have to use the law of sines, go through the situation, and see whether this supplementary angle works also. Okay, so that's essentially the way it works. And the key step there is when you solve that problem right there, always get both angles. Don't stop with that acute angle. Always figure out its supplementary angle. Because, I mean, if you think about it, the inverse sine of 0.803 is not just 53.46 degrees, it's also 126, right? Sine is positive in the second quadrant. Okay. And that's why this works, because the sine of 126 is the same number as the sine of 54. This is the first quadrant angle, that's the second quadrant angle.
All right. Could you use the law of cosines to figure it out?
No.
Okay.
Never use the law of cosines if you can use the law of sines. And I don't know whether the law of cosines will produce the ambiguous answer. In other words, I don't know when I'm looking at that. There are like 4 conditions that if all 4 of them are true, then you're going to have the ambiguous case of the law of sines. Rather than memorize those 4 conditions, I find it much easier to just go ahead and start solving the problem. Okay, and in the process of solving the problem, when you get to this step, make sure you come up with 2 angles, not just the first quadrant angle, both of them. And then determine whether this triangle can have that 126 degree angle where it's at. And the only way you test it is to add that to the only other angle we know, which is 40. Since 40 plus 126 is still less than 180, it leaves room for a third angle right there. If 126 plus 40 exceeded that, then I would just throw out that solution. I don't have the ambiguous case. This is the only possible triangle that can come from that. Okay. And if this only angle you're given is greater than 90, then you never have the ambiguous case. You only have to consider it if it's less than 90. Because obviously if it's greater than 90, then the supplementary angle to C is going to be greater than 90, and you're already going to exceed 180. Let's do another one from the start. You need to be able to do it. We only have 3 minutes, and unfortunately I got more. Do you have one more we could look at real quick?
Yeah, but not that I know if it has the ambiguous case. It says if it exists. I don't know.
Well, let's try one, and I'll give you a good estimate as to whether I think it exists or not.
Given that A equals 42 degrees, C equals 21 degrees, and B is 35.
Okay.
Determine
this is not the ambiguous case, because the moment they give us 2 angles, they've given us 3 angles. If you know all 3 angles, then you can't have the ambiguous case. In other words, if I have a triangle and I know that this one's 21 and this one's 42, then this one has to be 117. Well, there's nothing ambiguous about that. That's only one triangle that can have those three angles. So this is not going to be an ambiguous case. The only time you might have an ambiguous case is if they give you one angle and two sides, and neither side is opposite that angle. In other words, to try an ambiguous case, you would need a side B and a side C. And then we could check. Do you have any problems like that?
Sort of, yeah, I do.
Okay.
No. Yeah, I do.
Okay.
No, I don't. Never mind. They all give me two angles or more.
Okay, so you don't have any problems then for the, let's do one last with two angles. Although that's just going to be a simple law of sine. Oh no, yeah. If you are given two angles and one side, then you're always going to have an angle and an opposite side relationship, and you can solve the whole problem with the law of sines.
Yeah.
Only time you need law of cosines is when I have that angle and I have that side and I have that side. Notice that the law of sines won't do me any good here. I do not have an angle opposite side pair. So I have to solve this using law of cosines, and that is only going to solve for x. After I solve for x, I'm going to have to solve for this angle and this angle using the law of sines. Actually, I can solve for one of them using the law of sines, and then I'll know what the other one is, just knowing that the three angles equal 180.
Okay.
Sorry we don't have a little more time, because this subject needs a little more time. But you said you had a week and a half?
Yeah.
Okay, so we'll be able to cover this a little bit more next Tuesday.
Okay. Awesome. Thank you.
All right. Okay, Sarah, have a good week.
You too.
Bye-bye.
Bye.